Okay, thanks everyone for coming to the during lunch session. That's always a dreaded session, so hopefully I can try to keep you all awake. So as Brian mentioned, my name is Brent Insko. I'm lead software architect at Intel for VR. And today I'll be spending some time talking to you about what OpenXR is and why we're excited about it and why you should be excited about it. So what is OpenXR? So OpenXR is a high-performance, royalty-free open standard to connect AR and VR devices with the applications that run on them. So what does OpenXR do? So OpenXR handles the communications between the platforms and the applications. So an XR application such as the VR Valve Index or the Oculus Quest or the Microsoft HoloLens 2, they would provide the application information such as the head or hand poses, information about the controller states, whether you're pressing a button or not, and also any any display configuration of form factor information, such as if you have a single screen or multiple screens to display to. An application provides the XR device, the images that need to be displayed, any audio information that needs to be heard through the headset, and also any haptic responses that have to be felt through any types of controllers or vibrational responses in the controllers. So why was OpenXR needed in the first place? So if you consider the variety of XR platforms that are available from AR and VR, they range in display capabilities, tracking capabilities, environmental input capabilities, as well as controller styles and input mechanisms. And so before OpenXR, you had so many platforms out there that an application had to develop for. You spent a lot of time programming through proprietary software interfaces to each of the different platforms, trying to reach a really broad XR audience, which is still fairly nascent and the market is still very small. So this fragmentation across platforms caused problems. It causes increased developer time, increased validation time, because you have to test on all these different platforms through all their different code paths, and if a bug's in one code path and not in another code path, it's just painful. And so what we wanted to do was create a single API that the applications could develop towards that would provide a single high-performance API to all the different VR platforms and some of the up-and-coming AR platforms. So OpenXR handles all of the communications, all of the interfaces that you need to create a compelling XR experiences, but you need to pair it with a graphics API, something such as Vulkan, which is another one of the Chronos APIs, which is particularly well suited to provide the high performance, low latency rendering that you need to have to create compelling XR experiences. OpenXR is also very flexible, so we have support for both AR and VR devices. We have support across all-in-one and tethered devices, and we're also multi-OS. We have support for Android, Windows, as well as Linux. So I just want to flash this up here. We don't have time to go through a whole deep dive on what an OpenXR application and how it works. But just wanted to kind of show the flow of how you would build an application using OpenXR. So you can program it like you would a normal graphics API, or you can also use it through integration with some of the game engines, which I'll talk about in a few minutes. So OpenXR continues to accelerate its growth. We formed this committee to develop this in 2017 when a bunch of the VR developers said, hey, this is a problem, we need to try to get ahead of this. We spent a few years coming up with a specification and released it in 2019. And then we developed a conformance suite, because a spec isn't anything unless you can test against it and make sure the applications can depend on the platforms actually supporting it. We all started having released conformant implementations last year, and now that we have the platform supporting it, we're starting to see applications and experiences take advantage of it as well. So let me talk a little bit about the latest developments with OpenXR. So as I mentioned, we have wide adoption across the industry. So we have support in the AR device, Microsoft HoloLens 2. We also have support in mixed reality devices such as the Vario series of headsets. We have support in Steam VR, the Oculus platforms, both the Quest 2, and their PC tethered Rift. We have open source OpenXR implementation from Collabora as well. And we also have game engine integration. You can use Unity or Unreal to access OpenXR. We also have the backend support in all of the Chromium-based browsers that have the OpenXR supporting WebXR underneath the engine. The latest breaking development, which didn't make it onto the slide, if anyone saw the announcement this morning, Qualcomm has also released their Snapdragon Spaces, their development platform for developing XR, and it supports OpenXR as well. So not only are all these platforms supporting OpenXR, but they are also shifting all of their future development to OpenXR as well. So if you're starting to build up your application or you're starting to build up your game and you're thinking about what APIs to use, if you're wanting to be forward-looking, you should shift to OpenXR. In fact, companies like, I guess, Meta now has announced that they will be deprecating their old Oculus APIs in favor of OpenXR and moving with that going forward. As I mentioned, we're seeing a lot of applications start to use it as well. As I mentioned, the browsers all support it. Minecraft supports it, or will support it with their new rendering engine. Flight Simulator is already out there. If you have experienced VR with the Flight Simulator, it uses OpenXR. Blender uses OpenXR to deliver its scene inspection capabilities, and then we have games that are starting to come out that support it as well. So this is just a scene from Blender where you can don the headset, walk around your scene, and check it out. We also have major titles coming out or that were just released. This was just within the last couple of months. The Zombieland VR uses OpenXR to support all of the PC platforms with a single executable. And it was built within Unity, so it showcases all of the capabilities of OpenXR. So what's next for OpenXR? So OpenXR is similar to all of the other Khronos APIs, which some of you may or may not be familiar with, but basically we build a core API and then we extend it with additional capabilities. And this just talks about some of the capabilities of those extensions through the Khronos APIs. And so we had a number of extensions at launch. I think we had 12 or so extensions, including some of the graphics API support. Now we have 72 extensions. And this, when you look at when we released the API back in 2019, you might think, oh, well, you're still using the same core API. It's like, yes, we wanted a very stable base while all the platforms could develop to. And then we allow them to start experimenting, right? We're all in this experimental mode with AR and VR. So this just is a list of, like, we are making forward progress. Lots of work is being developed, and we really want to get some experience with how we want to frame the APIs across all these different platforms. And I'll talk about a few of these extensions in particular in the next few slides. But you can see some about hand tracking, spatial anchors. So one of the directions we want to go in the future is adding more and more AR and mixed reality capabilities to the API. So one of the extensions I want to talk about is overlays, which is being able to overlay one experience on top of the base experience. And so here you can see a couple of examples where you could be chatting with somebody as you're flying between planets, or you can be within Steam Home and have conversations there as well. Another extension which took a lot of work was hand tracking. So we have controllers for most of the VR platforms, but we've now integrated an extension for real hand tracking. And this represents a lot of work from a lot of the member companies, Meta, Microsoft, Valve, Magic Leap, et cetera, because they all had their different platforms. They all had different ways of expressing hand tracking. So coming up with what the joints are, how to give that ability to the developers to get access to the underlying platform's capabilities took a while. So we can do this with the hand tracking extension. And let me see. And then this just shows the hand tracking extension paired with Stereo Kit using OpenXR and the UltraLeap OpenXR API layer running on mixed reality. And so you can see real hand tracking interacting in a virtual environment. Okay, and along with hand tracking, we're pushing other advanced UI capabilities. Well, we have an eye tracking extension that Toby worked on, and it's shipping with the HoloLens 2, so that you can do real eye gaze interaction, so you can track where the person's looking and provide some easier natural aiming in those types of devices. Also want to talk about how OpenXR can also look to the future of where applications are going forward, and what the location of computing is going to look like with these devices as they come out. And so one architecture being considered is using 5G to pair a really lightweight VR headset with kind of enormous rendering capabilities at the edge, so that you can deliver more compelling XR experiences while it's still delivering a comfortable wearable device on the head. And so what OpenXR can do is it hides this complexity. So if you build your application to support a single device, it will run in this configuration as well, because the application doesn't know what's underneath. You can do all the communication through OpenXR, all the sensor handling, all the display composition through OpenXR. So, and this is real, this is happening. There are companies out there that are delivering these types of experiences. I think mostly still in the lab, although I'm sure at the conference people will talk about this going forward. So what's in the future for OpenXR? So as I mentioned, we've released the 1.0 specification, which is great, but you always find things like, wow, we really should have done this differently, or this isn't working out, as we're getting more and more experiences with real applications. So we're gonna go back and fix some things. We're also expanding support for AR and MR. So as I mentioned, we're doing real hand tracking. One of the other ones we're looking at is scene understanding. How do you communicate what the scene is in the environment? What are the security protocols, the privacy protocols, all those sorts of things. We're trying to steer clear of that because that gets really complicated. But how does the platform support it and communicate to the application? And then another area we're looking at is additional user input and output capabilities, expanding haptic support, body tracking, and more controllers. Like one of the areas that we're really proud of OpenXR is our input mechanisms, because all of these controllers have different capabilities and different interaction abilities, and we don't know what the future of the controllers look like. And so we really want to build a lot of flexibility to allow the user to control it, right? Say, okay, I don't want my jump button to be on the left hand, I want it to be on the right hand controller. We also want to be very accessible, right, to allow people who have different abilities to be able to experience the XR experiences. And so being able to swap the controllers around, or even having games and applications that currently support OpenXR be able to be playable on the platforms in the future where you have no idea what the controllers are going to look like. So as I would also like to talk to, we have a lot of companies that are supporting OpenXR, and they continue to grow. We have more and more companies coming in and helping shape what the future of the API looks like going forward. And they're starting to see the benefits of being able to get their platform more and more applications, because if they support OpenXR and you're not potentially one of the major players, and applications get developed onto OpenXR, the applications will work on your platform. And so one of the reasons that we feel OpenXR is gaining such wide industry adoption is it's really a win-win for everybody involved, right? Because software developers can write their application once and get it supported on a number of different platforms. The platform developers can build their devices and support the OpenXR API, and get access to a large library of OpenXR applications and know that they will work on their platform. And then the end users win, because in the end, they're going to choose a device that they want to use, and they expect the applications and the experiences to be delivered on the devices that they end up purchasing. So OpenXR is on an HMD near you or device. As I mentioned, it's also specifically to AR, it's on the HoloLens 2. We have lots of officially conformant runtimes. As I mentioned, Qualcomm just announced they have a developer platform as well. And OpenXR is being used by real software from Unreal, from Blender, and Chrome, Edge, Unity, Flight Simulator, games, etc. So how do you get started? So we have our main page at openxr.org, or you can go to the Kronos website, get to it from there as well. We also have forums and Slack channels where the members of the working group, can communicate with the developer community and give you information and feedback about, and you can provide us feedback about what you would like to see in OpenXR going forward. We have a 200 plus page specification if you're interested in reading it. We have reference pages, so if you're programming directly to it, you can get information that way as well. And we also have like a 6 or 7 page overview guide that kind of walks through the life cycle of an OpenXR application and how it works. We have a number of GitHub resources. We try to make sure everything is open source, so as we develop things and get them pushed to the public, everybody can get access to it and provide us information back in directly, making changes and telling us, hey, this is spelled wrong or this interface isn't right. You can give us information as well. So we have 3 different repositories where we have lots of information about OpenXR. We also are starting to get member companies to have their own support and capabilities and show you how to use OpenXR as well. We have great support from a number of these companies, Microsoft, Meta, Ultraleap, Unity, Unreal, et cetera, where you can get real examples of how you use OpenXR and how to integrate it into your application or your platform. So Khronos has multiple standards. It's really on the forefront of where extended reality, mixed reality, augmented reality, virtual reality, any of the realities you want to talk to. We have the support from, support on the 3D side, where we have the Vulkan low-level API for graphics. We also have WebGL that supports browser-based 3D graphics. We have OpenXR, which I'm talking about, which is pushing the portable XR experiences across a number of different platforms. And then what's really gaining traction are the GLTF and the 3D commerce working groups. So GLTF is a format which allows you to transfer information about the assets that you are creating. So things like, if you're in retail, what your potential shoe looks like, the material properties, et cetera, so that it can be faithfully recreated in the 3D world through a browser or through 3D experiences. So there's lots of work on the GLTF. And then we have the 3D commerce as well, which is really about how do we build the capabilities to really make retail and commerce happen on the web, and how do you communicate your product faithfully? If any of you all were in one of the sessions before with Snap and Deloitte talking about, one of the things that they're seeing with their brands is the ability to try things on in AR before or check out how the couch is going to fit in the room. You're seeing a lot less returns. I think they said 25% less returns if the brands have an AR experience where the user can try things out before. So this is just going to continue to grow and grow, and 3D commerce is one of the fastest growing working groups within Khronos. So if you have interest in that, I encourage you to check out Khronos, become a member, and maybe join the 3D working group. And with that, I'm approaching 5 minutes to go. So I can keep talking, or if anyone wants to have questions, I'm happy to open up for questions as well.
Awesome.
Okay.
Thank you, Brent.
Thanks.
Questions? We do have a microphone in the middle there, or I can walk around with the mic, but does anybody have a question for Brent? If so, I'd say get up on the mic there, or I can find you if you raise your hand. We got a question over there. I'll come over to you. Take the mic.
Hi, thanks for the presentation. So,
Sure.
From the perspective of an application or like experienced developer, how much is it worth knowing about OpenXR? For example, if you're using WebXR to develop something, how important is it actually to know the underlying layer, or is it more of a concern for, let's say, browser implementers?
Sure. I would say that, yeah, if you're developing WebXR experiences, it's probably not directly something that you need to know about, because you'll be programming to the WebXR and then being supported through the browsers. I will say a couple of points on that. The WebXR committee and the OpenXR committee both share many members, and so we're trying to stay in sync so the two APIs don't diverge, because you want to have as close a relationship between what the WebXR application developers see to the underlying support, because you don't want lots of layers to be don't want lots of translation layers between the two. I would say that though, as you see things that maybe aren't supported in WebXR, communicate with WebXR or make sure you're communicating with us as well. I'd also say, we have lots of game engine support as well, so maybe you're deploying through a game engine to WebXR because they can output to WebXR as well. Maybe not totally, you don't totally need to get down to the low level of OpenXR, but it's, I would say that there are lots of ways to get access to OpenXR depending on the level you want to. But if you want to get down in the low level and figure out, build your own without going through game engines, then yeah, you would want to know about OpenXR. Thanks.
Yeah, hi, my name's John. This might be a can of worms, but you mentioned scene understanding, and then we've been seeing a lot of different SDK type things out there trying to do scene understanding. Almost every vendor has something going on. So
yes.
When you're conceptualizing that, are you going to try and let those things interoperate, or are you going to replace them and create another standard and have that XKCD comic?
No, that's, yes. You have 14 standards and, you need a 15th standard.
It's definitely a can of worms, but
yes.
It could be a unifying place for those all, where I could say I want this semantic, it works well here, but that meshing works well there, and you could help us recover our sanity. That would be nice. I don't know.
Yeah, no, it's definitely something, and that's why we don't have a scene understanding extension out there yet. But that's one of the benefits of like the Kronos APIs. You have an extension, and it allows companies to play with like, okay, is this the right semantics to use, the right API interfaces to provide? I know there are multiple companies. We may see multiple companies within OpenXR release their own spatial awareness extensions because they may think of different things, and then we'll let the developers decide, oh wow, this one worked way better than this other company's, and then everybody kind of gravitates to that, and then when we get ready to roll it into the next core release of OpenXR, that would be the one direction all the companies then would push forward with. So yeah, we don't want to create any more than we have to. So yeah, I think there was one over here. Yeah.
I just wonder, I saw Apple wasn't part of the original, supporting group of companies, but I'm just curious, are they just, is the answer a flat no? Is there an ongoing discussion with them? What's the likely future there?
Yeah, so I would, I can't talk too much about the internals, but Google was also one of the early members as well. I would say that, there is, obviously communication between the groups. I think, there are multiple ways OpenXR might hit some of those platforms that maybe don't directly support it. We might have translation layers that would go from ARKit or ARCore to OpenXR and vice versa, so that you get, because we do want to make sure that it's the cross-platform API that you develop towards, right? So if you develop to ARCore, ARKit, you're limited to those specific platforms. That is one of the things on the list we want to see, is being able to have the translation layer. So if you develop on OpenXR, it will run on platforms that don't directly support it as well. So it's a good question. We get that a lot. Okay, yeah.
Yes, hello. So lately, I feel like both within the broader XR community and also within the MIT Reality Hack community, we've seen a lot of interest in reusability at a higher level.
Okay.
So for things like avatars, rich virtual scenes, user-created content, it seems like a lot of platforms have their own solution, but
yes,
people are looking for ways to cross over. Do you think the Kronos group has a role to play there with potentially other standards at a high level?
I think so. There's a couple of different things. There is, the 3D Commerce group is looking at that to some degree about, kind of the higher level interfaces of what scenes would look like. I think there is some discussions about maybe even needing a separate work group to think about that. I know within the OpenXR group, we're looking at, how do you represent people? How do you define what an avatar is? What are the capabilities? What level of scene understanding, to the earlier question, do you provide? Do you just provide flat surfaces, or do you want to provide a richer set of, is this a vertical surface, a flat surface, or do you want to go beyond that with some semantics? Spatial anchoring, what does that look like? What underlying core technologies do we use to locate things, and how do you share spatial anchors with, is there a common coordinate system for the entire world down, because I know there are standards pushing that as well, right, to provide around the world one set of coordinates for everything, and does that make sense, going forward? So.
Great, thank you. And if I could just have one little follow-up.
Sure.
What do you see as being the best way for just members of the community to get involved in these conversations?
So I would say, as I mentioned, their Slack channel, specifically for OpenXR, a Slack channel, our GitHub repositories, if you find issues. We've had recent discussions about color spaces where like things what we thought about, but then we didn't think about enough, right? We're like, oh, I want my logo to look the same color across devices. It's like, why doesn't that work, right? And you start talking about, what do we need to do to fix, little niggly things like that, and then also big things like, we are developer focused. If there are specific things that you want to get access to on the underlying platforms, then let us know, and because we want to provide those APIs to the platforms because we want you to develop the really cool XR experiences, right? So.
I think we got one more, Brent, and then
Okay,
we'll
sure.
wrap it up.
Fit it in really quick. Okay.
Could you comment on the licensing? And in particular, would the licensing be attractive to both industry and government?
Yes, so it's completely open license from an application developer perspective. It's totally free to use from an application perspective. The way that we work is that when you develop a device, we test it. We have a conformance suite to test that the device, say the Quest or the Oculus Quest or the Valve Index or the HoloLens 2, we provide a test suite to make sure that they're going to support the applications. And the devices provide the payment for the conformance suite and get access to becoming an adopter of OpenXR. And all this is on the Kronos website. And so it's royalty free, but if you want to use the logo to say, hey, my device supports OpenXR, you need to go through this process because we want to make sure applications will work, and we keep the name OpenXR, meaning that if you develop for OpenXR, it's portable across multiple devices. So. But we have both industry and government members working on the APIs. So and more specifics on the licensing, because I'm not a lawyer, can be found on like the Kronos website as well. So. Okay, I think.
Thank you, Brent. Let's give it up for Brent.
Appreciate it. Thank you all.